Alright, my name is Samuel George, and this is my Comp533 Assignment 1 demo. I'm going to be following the rubric here, and I'm going to do the first part of the first video is going to demonstrate that all the clients respond to changes, as well as walk through this debug mode. The second video is going to demonstrate inconsistency, as well as the atomic solution, and the third one is going to demonstrate my GUI, changing from local to broadcasting mode, and as well as my pre-written code. Just as a basic walkthrough of my code to show what's going on. In this initial test, I would just basically start up a server and 3 clients and show that they're synchronized. So for the first part, let's just go ahead and start this up. So we have these 3. So we can move. All of them responded and moved. And we'll walk through the events as they go down here. Okay, they're going to go up the driveway and then take a walk. Okay, so all 3 clients respond to commands given in any of them. It's also worth noting that this is my consistent version. So just to sort of look at the code real quick and get an understanding, we're going to close those guys. Mainly what's doing the code is this boat client. Each client is an NIO client, which basically opens a single connection and maintains it to a server. This is my final version, so it's worth noting this is the consistent version. For the inconsistent part of the demo, I'll show this, but local processing is turned off. It also has an observing simulation and is a property change listener. So the observing simulation will fire off the command. A property change event will occur inside the client. The client will then send that to the server. It will get back a response here, and that's what this handle response does, and it's going to queue it up into a blocking queue. That blocking queue is on a separate thread for remote operations, which actually does the command. So we're going to walk through each one of those pieces and show how they work. Threads are also named, so we're going to walk through that. For the demo, I'm just going to use 2 clients just for so there's no confusion. So let's start this guy up in debug mode, and we're going to walk through the rubric here and show each part. So the main thread is getting ready to invoke connect, so let's change over, and here's the main thread, and in my client it is waiting to connect. So we're going to allow it to connect, and then of course we're going to let it finish the connection. So that covers the client. Main thread invokes the connect, and then finish connect, as we can see in here, is in the selector thread. So it's getting ready to execute finish connect. The second client is also going to connect, and he's also going to finish connect. And these are tracked over here. So again, the client finished its connection, the main thread initiated the connection, selector thread registered and finished the connection, and now they are waiting for commands. So let's spread this out, and what happens when we type in a move. Okay, so the first order of events, the command processor within this client here has fired a property change event. This is to cover here, so we can see it's the AWT thread here that is firing the property change event. After the property change event's fired, the client listens to it and says we're going to send this, whatever the command was, to the server. This in turn is going to activate write. So you can see this send data involves a write. So now sending, the key for that socket says, hey, it's time to write. So he gets write, and the client writes to that socket channel. So this shows the AWT thread did its property change, and the selection thread in turn did a write. We're going to show the reading of the remote commands afterwards. So we can see down here we have written, and we see the write, and now we can see the server. So just for clarity's sake, I showed the server actually getting ready to read the channel that we just wrote on. So now we're in the server is getting ready to read, and it's just red. Actually, it's just red, and we're going to show the trace down here, and the server read. It then changed and says, okay, after it read, I need to write to both of the channels, socket channels that these two are listening on. So both of them changed their interest in writing, and they're both going to write. It's going to write to both of those channels. So one write, two writes. Now we're back into the NIO client. So this client here is now getting ready to read what was sent back by the server. So this is to show the read in the selector thread. It's getting ready to read. And it does. It just did a read. And we have this breakpoint here. And we will see selector read. After it's read, it will add to the blocking queue. It takes the byte version of what was read, makes it into a string, and passes it into the blocking queue, which will then in turn wake up the remote operations thread to actually process the command. I would expect we'll see both of these queue before we actually do the remote operations. And sure enough, here's the second read for this client. So this client has read, and he's not actually initiated the read, and he's about ready to add it to his blocking queue. So that's a remote command is read, and after receiving it, it's going to execute it. So both threads, or both clients, have a separate remote operations thread, which is going to handle the commands. So now they've woken up and said, I have a command that needs to be processed. So the first client here has gotten his process back. You can see in the remote operations thread, he's getting ready to execute the command, and he does. And then we see the second client, also his remote operations thread is woken up due to the read, and he's going to do the command as well, and that ends the loop. So we see that after receiving the command, the process command method is executed, and these are all the traces showing back what happened. So this covers the first and second part of the demo, showing the mode of operations. Again, in the second part, we'll dive a little more into the code and show an inconsistency as well as my demo.